when we left off. We were just checking to see if the point in our shaded region was actually a solution by plugging it into the original inequality. And we found that 6 minus 1 made 5, and 5 is greater than negative 2, so it is true. This is really a solution, and that is one other way you can check to see that you shaded in the correct area. Another thing we're going to be doing in this lesson is coming up with the inequality that matches a particular graph. So if you look at this first one, we can see it has a vertical line, and we know that vertical lines cross the x-axis. Therefore, we know it's going to be x compared to some number. And you can see here that it's crossing at positive 1, okay, and it's shading to the left. So compared to 1, we're shading 0, negative 1, negative 2, so we're shading less than 1. And the dot line is dotted, so we know not to put an equal sign here. So this inequality is shown as x is less than 1. Okay? The second one you can see has a horizontal line, and a horizontal line crosses the y-axis, so we know that this is just going to be y compared to some number. You can see it has a solid line, so we know that there's going to be a equals in there. And we can see that we shaded above, and these are bigger numbers, so we know we're doing a greater than. Y is greater than or equal to some number. And then all you have to do is see where you crossed at. And this appears to be negative 1, 2, 3, 4, 5. Negative 5. So that is the inequality y is greater than or equal to negative 5. Anytime you have a single variable in your inequality, you know it's either a vertical line or a horizontal line. For all diagonals, you're going to use slope-intercept form to write your inequality. So you have to figure out what's your b, what's your m, and what type of symbol are you going to use. So for this one, we can see that b should equal 3 because it crosses here at 3. For slope, I'm going to count, and I'm going to go, okay, up 1, 2, 3, and over 2 to the right. So up 3, over 2 to the right makes it positive 3 over 2. And then I'm going to write y, 3 halves x plus 3. And now I just need my symbol. Compared to my y-intercept, we shaded below. That means less than. And since the line is dotted, I know there's no equal sign. So the solution is y is less than 3 halves x plus 3. The last activity we're going to try here is writing and graphing a linear inequality for a situation. Let's say you're hosting a party and you could spend no more than $24 on snacks. No more than 24, so there's our total number. You can buy potato chips for $4 a bag and mini donuts for $3 a bag. So potato chips is 4, donuts is 3, total is 24. So 4, then let's make potato stand for x and donuts for y. You can pick any variables you want. I like using x's and y's if I'm going to have to graph, because that's something I'm familiar with. So 4x plus 3y is going to be compared to 24. Now I can spend no more than 24. So that means I can spend less than or equal to $24. Okay? There's my written inequality. That's the first answer to my problem. Now I need to graph it. So I need to get my y variable by itself. So I'm going to subtract 4x from both sides. 3y is less than or equal to negative 4x plus 24. Okay, and I'm dividing both sides by 3. So y is less than or equal to, and I divided by a positive, so I don't have to flip anything, I don't have to worry when I divide by positives. Y is less than or equal to negative 4/3 x plus 24 divided by 3 is 8. There is my inequality. So now I'm going to graph it. Start from your y-intercept, so 1, 2, 3, 4, 5, 6, 7, 8. And then my slope means 4 down and 3 to the right. 3, 4, 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. And the more dots you make, the better chance you have of getting a good line. And Now I need a line that is solid because I have an equal sign. And let's just make it a green line for fun. Alright, there's my inequality graphed. I still have to shade though. When you're working with word problems, think of the reality. These are potato chips and donuts. Can you do a negative number of potato chips and donuts? No. So, I'd encourage you to stick just in the first quadrant for most word problems. Think about it logically. So, y is less than, so I know I'm shading lower than my line. So this is the area I want to shade. Everything smaller than my line. We're going to come up with 3 possible combinations of donuts and chips you can buy. We're looking for 3 solutions to the problem. Remember, a solution to an inequality is any ordered pair that makes it true. That means anything in this shaded region and anything on the solid line would work. For the sake of fun, I'm going to make up 3 new points that are in that shaded region. So x is 1, y is 4. So 1, 4, I could have 2, 1, or I could have 1, 2, 3, 3, 3. And because ordered pairs don't mean anything unless you know what they stand for, remember that potato chips was x. So I could do a little chart here maybe to show that I could do 1 potato chip with, donuts was our y. 1 potato chip and 4 donuts, 2 bags of chips and 1 bag of donuts, or 3 bags of chips and 3 bags of donuts. Okay? So when you're listing combinations, make sure you somehow describe what they are and not just give ordered pairs, if you're in a word problem. Okay? So things to remember, turn them into slope-intercept form always before you start graphing. And if you multiply or divide by a negative, make sure you flip that symbol in your inequality. Good luck!